Hey, Jessica, it's a real honor to be talking to you today. I really, really appreciate the time. Apparently, we were at Brown for a brief moment together. I think you graduated in 1999 as an undergrad.
That's right.
I was there during the late 90s doing my PhD in the ecology and evolutionary department.
Okay, awesome. Yeah, good time to be in Rhode Island.
Yeah, it was fabulous. I really enjoyed my time at Brown. I was a Middlebury undergrad, um, but yeah, it was a great experience. Uh, let me sort of just jump into a couple of questions here. I know obviously you're an astronaut, but you're a marine scientist too, and I want to talk about the connection essentially and the analogies between the ocean and space. But you had these two interests, I think, from the very beginning. Is that right? And the question is, which came first, your interest in the ocean or your interest in space?
Well, maybe both, but I think, to be honest, probably the interest in space. And that's only because I didn't actually grow up in the ocean. So I grew up in a really small town in northern Maine, up so far north that Canada flanks that eastern border instead of the ocean, like most people
Okay,
think of with the coast of Maine. So
sure.
I started saying I wanted to be an astronaut when I was 5 and pretty much said that all the way through. And I think my passion and love for the ocean came a little bit later after that when I was exposed more to the water and the ocean and had more experience in it.
Okay, so and you got interested in scuba diving at some point along the career, right? I too was an early diver. I got certified when I was 13 years old, which at the time was the youngest you could become certified. And I was just wondering
Awesome.
where that started.
Yeah, and I think the deeper connection too was just really this passion for biology and nature. And maybe that's something that connects it all, and really this drive for exploration. And I think that was something that did start from the time I was a young child. I had this curiosity, about the world around me. I wanted to understand more, especially about nature, how things worked in nature, what made these animals capable of doing these incredible things. And because I grew up in that small town, lots of trees around, my mom's from Sweden and they have quite a strong connection to nature. So I think that's what it was that drove that scientific curiosity and that yearning for exploration. And the first time that I started scuba diving, that was when I was an undergraduate at Brown, actually. So,
Okay.
now I was spending a lot more time closer to the ocean and I really wanted to dive. And again, I think just because it's another avenue toward exploration, more than 75% of our planet covered by water, of course. And as you know, this whole other world is beneath the surface of the water. That's something I feel so passionately about, trying to get everybody to get underwater and experience that, because it's, I don't really think it's something you can see, certainly not from the surface and not even from photos and video. So I did my scuba certification while I was an undergraduate and did my checkout dives, my first open water dives in the ocean right there in Rhode Island off of Jamestown.
Okay. Yeah, great. I did my checkout dives off of Massachusetts. And
Okay.
then I came to California to study kelp forests many, many years ago and was kind of blown away by the kelp forests out here, which are really my special place still. They're essentially the underwater redwoods of the sea. And I think you've dove in lots of places around the world. Now, what's your favorite spot? What's your favorite habitat?
Well, my favorite place to dive, hands down, is the Antarctic. And I was extremely fortunate to get to dive down there. But that wasn't without training and learning how to use a dry suit right there in those California kelp forests that you were just talking about.
Oh,
So
okay.
now, yeah, so this was when I was a graduate student at the Scripps Institution of Oceanography.
Yeah.
And part of the scientific diving course there, I was learning how to use a dry suit for the first time before I had my first research trip to the Antarctic to study the diving physiology of emperor penguins.
Yeah.
So lots of great dives. I mean, really, that diving in Southern California and specifically right there around La Jolla and the canyon is astounding, as I'm sure you remember. And that was something for me to get used to. I had never been diving in a kelp forest like that, and all those additional challenges of getting tangled up in the kelp and making sure, it doesn't get wrapped around your tanks and your regulator. But that was something after I had been working at NASA for a few years. I actually did an underwater mission as an aquanaut in the Aquarius habitat, and that was a NASA mission, the NASA Extreme Environment Mission Operations. And that, I think, was what set me back on this path toward the oceans. I had done some scuba diving since my certification, but not enough since I was a student most of the time and didn't really
Right.
have the money. And when I was here working at NASA as a scientist, there was a call for one of the first, this is the fourth NEMO mission. So now we've done them really since around the year 2000 or so. So there have been a lot since then, but this was kind of early on. And NEMO was being used as a training atmosphere for astronauts. It's an analog environment. So as you can imagine, living and working and training underwater in a small habitat is a lot of parallels that we have with the space station. So it was being used for astronaut training and then also starting to be used for some hardware analog testing. And I worked for the life sciences directorate back then, and they wanted to send a crew member. So I actually went, you had to have a certain number of dives, and I didn't since I didn't have a lot of experience yet. So I took a vacation. I went to Bonaire for 10 days and was diving, every day, several dives, came back and applied for that. So I was fortunate enough to live and work in that underwater environment. And that's really what reinvigorated this passion for the ocean and thinking, how can I combine this exploration and my interest in biology for going back to school? And that's one of the things I think that drove me toward Scripps Institution of Oceanography and the research that was being done there with diving animals.
Yeah, no, that's a great career path, and fascinating research on some of these deep diving animals. At the end of the day, though, apparently space won out, right? That's your primary gig at this point is being an astronaut, right?
Yeah, it's interesting. If I think back to those first trips to the Antarctic and diving down there, it was one of the first times that I'd really felt this feeling of content, where I had this physical and this mental challenge, living and working in a harsh environment, diving underneath the sea ice in a dry suit. Sometimes you're just shoveling snow all day to take care of the penguins instead of doing science. And that's what really inspired me, combining both the mental part of designing these experiments and carrying them out, but then also with that physical challenge as well. And I think that's the big parallel between that kind of setting, living and working in a technical underwater environment or in the Antarctic, and then living and working in space. And I look at it really now as an astronaut, it's this ultimate combination of that physical and mental challenge. So I am working full-time now as an astronaut, but I can tell you still very passionate about the oceans and wanting to get back there every time I can. And that was one of the things about my mission as well. This extraordinary view that we have of the Earth when we are about 250 miles above. First of all, what do you see? A lot of times you just see only ocean. As we know, most of our Earth's surface is covered by ocean. And that perspective, looking down from the space station, it is very plain to see that we live on a blue planet, like we say. It's very difficult to miss. So those views, I think, make me feel even more passionately about the Earth and about the oceans and about our need to protect it. Seeing that from space, you just realize automatically how beautiful, how fragile, how special and unique our planet is, and how it is absolutely our responsibility to protect it. And that was something, I thought a lot about before going to space, but it resonated even more loudly when I was up there and had that incredible view.
Yeah, I suspect that is definitely true. And of course, only a few people on planet Earth have had that perspective from space. From both a planetary perspective and an ocean perspective, climate change is the big existential threat out there. And I'm wondering, as you have circled the planet and seen it from a distance, like how has that changed your perspective on climate change in particular, and how we essentially confront this planetary threat?
Yeah, it's one of the things that I thought a lot about before going to space, because I have always had this passion and interest and drive to make sure that we are doing our best to protect this planet. And I've heard a lot of other astronauts say that, even people that hadn't really spent that much time thinking about it beforehand, how much it changes you when you have that privilege of seeing the planet from above with your own eyes. And there's even a term for it, really, the overview effect of how you change as a person when you have that opportunity. And a lot of that has to do, one of the big things has to do with exactly what you're saying. So many people, it's impossible to not see how special and beautiful and unique our planet is, this sparkling blue gem below you in the void and blackness of space. And you see the oceans, you see the interconnected land masses. And I think, first of all, that drive, that appreciation for how fragile it is and how we need to protect it, but also how connected everything was. And I think think that was something that was a little bit novel. I thought a lot about the environmental component before going, but I hadn't yet fully appreciated how connected everything was. When you are the only thing that's not on the planet and you're looking down at those continuous land masses and the ocean, you don't see any of those borders, those man-made boundaries that we've imposed upon ourselves. And you realize that we are truly all in this together. You know, whether that's from the climate standpoint and that we need to work together as a whole human species on this planet to do our best, or even thinking about things like, I actually was up there watching the pandemic unfold. When I launched, there was no COVID-19. We landed, you know, in the middle of it. So seeing those kinds of global wide phenomenon, climate change, the pandemic, civil unrest happening at different areas around the world, you know, it's just such a powerful perspective to see it from up there. And it's unavoidable to realize that we're in this together. We're one human and we are all connected, and we need to remember that. When it comes to climate change, you know, it is a responsibility that we all have. It's not just us protecting our own little microclimate here in the United States. We know that what we do, what we produce, what goes into the atmosphere has ramifications for the rest of the planet as well. So everybody needs to take responsibility for their actions.
Yeah. Well, I mean, you know, the ocean is a big place, right? For if you've been out on the ocean on a boat or scuba diving, there's a lot of water out there, hundreds of millions of miles of water. And yet it's very small when you get the right perspective on it, I suspect.
Right. Yeah, absolutely. And, you know, it is something that, aside from my personal thoughts about it at NASA, it is something that we are very much involved with our objectives, with our science objectives and our mission objectives actually here at NASA. And, you know, some examples of that, particularly with this new administration, as you know, there's such an emphasis on climate science and making sure that we are doing all we can to take that responsibility that we were just talking about. And actually just in May, just this past month, we've seen the Earth System Observatory come into fruition. And that was proposed between the White House and NASA in looking at all of these different climate science variables, extreme weather, climate resilience, adaptation and mitigation, you know, looking at aerosols, cloud convection, precipitation, all these parameters that shape our atmosphere, that shape all of the weather cycles and climate on our planet. So that's really exciting that we have this new NASA initiative. There were also several experiments that were up on the International Space Station when I was up there. Sometimes these things get a lot less press than some of the other experiments because they don't involve humans. You know, when I'm inside the space station, we have lots of pictures and lots of documentation of the things that I'm the subject for. So how spaceflight and microgravity affect the human body and all the different types of science that we're doing every day on board the International Space Station. But we also have a whole suite of instruments that are mounted on the outside of the space station. We don't have any interaction with those because really they are just passively collecting the data that we need that are all extremely relevant to climate science. And some examples there, we have a lot of different remote sensing instruments. We have an instrument called EcoStress, which is a spaceborne thermal radiometer. So that's looking at high spatiotemporal resolution thermal infrared measurements. So looking at some of these responses to climate change. We have the HARP, which is a CubeSat that it's demonstrating a technology for measuring the properties and size of aerosols and cloud droplets and cloud ice particles, and several other examples measuring CO2 in the atmosphere, for example, looking at sea surface temperature, looking at topography and forest cover. So all of these instruments are actually out there, part of the International Space Station, and gathering all this incredibly valuable data for climate scientists. And one of the things that's another exciting example is one thing that we are involved with as astronauts, and that's called our crew Earth observations photos. So these are just photos that we are taking all the time from the incredible vantage point that we have. But now that the International Space Station has been up there for really more than 2 decades, we have continuous photos passing over the same spots on Earth. So for example, I took quite a few pictures of the glaciers in Patagonia, the Patagonia ice fields. And so we can actually give those photos to scientists to help monitor and document the retreat of some of these glaciers. We also have examples of taking photos of deforestation, taking photos of different fires that are raging across the United States and all around the world. You know, when I was up there in the last huge bout of fires in Australia. So we have documentation from our own photographs for all of these phenomena as well.
Yeah. No, that's super interesting. I mean, I would think the general public generally thinks of astronauts and the space station as essentially studying space. But in fact, the whole system, it sounds to me, is designed to provide insights into the Earth as well through all these instruments and science and data that's being collected in real time up there.
Yeah, that is exactly right. And that's one of the biggest benefits that we have with our space program in general and the International Space Station too. We have a slogan for it, you know, it's off the Earth for the Earth, because so much of what we do is actually geared toward giving back to life here on our own planet, figuring out how to protect it with all of these climate science initiatives like we talked about, and also other applications in terms of the population here on Earth. You know, some of the medical experiments that we do have direct applications to disease states on Earth that normal humans here that are Earthbound are experiencing. So all of these things really do help us with life back on Earth as well.
Yeah, so talk to me just a little bit more about that. I mean, I think there are some cynics out there that think that the money that we spend on space exploration should be better spent here at home, trying to solve our problems. This idea that, you know, we'll go to other planets and find another place to live and we can move off of Earth, or that it's a luxury. And what I hear from the way you describe the work there is that no, this is actually not a luxury. This is about getting a better insight into our planet, but from a different perspective.
Right. And, you know, of course, that's an argument we hear a lot. And I do agree that we do need to make sure that we are financing the right science here on Earth, the right initiatives here on Earth to make sure that we are bettering life for all of the humans on the planet. That is absolutely true. I just don't think that you need to do that at the sake of any kind of basic science and exploration as well. You know, the NASA budget is really only a tiny, tiny fraction of what we are spending our money here on in the United States, and the rewards that we have in terms of, first of all, just that basic science in general. You know, so many times the most incredible findings and results of scientific experiments are those unanticipated ones. You know, we have countless examples of that back here on Earth. The same is true in space, and these experiments have vast applications for life back here on Earth. But you know, I think it's also important to remember, you know, some people compare a lot to the budget that we spend on oceanographic research, right? There are a lot of skeptics even in the oceanography community that think we haven't even finished exploring our planet and the depths of our ocean, and we're spending all this money on NASA. And, you know, again, I do think we should be funding all of those initiatives more broadly and more in depth, but again, not at the expense of the other. I think all of these things are incredibly important. And the other application for everything that we're doing here at NASA and with space exploration, another thing to think about is the secondary effects that you have on all of the STEM fields. So science, technology, engineering, math. When we fund something, take for example, the Apollo program. You know, we were getting ready to go to the moon in the 60s, and we had this huge burgeoning of resources in all of the STEM fields. That has paid dividends far beyond that of the space program. You had so many people involved in the STEM fields, and there are applications all over, to the earth sciences, to oceanography, to technology and development. The same thing, for example, will be true with the Artemis missions, our efforts to go back to the moon. So there are all these different entities and levels, I think, of these effects that sometimes it is just a little bit difficult for people to see if you don't try to really think about that in depth.
Yeah, yeah. So that it's more than just about Tang, I guess.
Yeah, absolutely. That was actually never a real thing.
I didn't think it was. So, you know, if we think about it, so at Ocean Conservancy, we strive to protect the oceans, right? And we focus on the big threats to the oceans. We've talked a little bit about climate change. One of the other big threats to the ocean is pollution, in particular, plastic pollution. You know, the science says that something like, you know, 11 million metric tons of plastic are now flowing into the ocean on a regular basis. And, you know, there might be an analogy here in space. I mean, we hear about space junk in space, and I'm just wondering, you know, how much garbage essentially is in space, and where is that coming from? Like, we know that plastic is coming into the ocean primarily from land, but why do we have a garbage problem in space, and what can be done about that?
Yeah, you're right. That is a great comparison, and it is a big problem in space now. Space debris or space junk, we call it, and that is basically fragments of old satellites, for example. Or so, you have a satellite that was up there, it's at its end of life. Maybe it gets hit by something, it breaks up into smaller bits. Depending on what orbit it is, it may not be close enough to the Earth to re-enter and burn up in the atmosphere. So we actually have clouds, like entire clouds of space debris and space junk orbiting around the entire planet. I've seen some of these recreations of that NASA will do, because we actually do track a lot of those pieces of space debris and junk over a certain size. And it is incredible to see the amount of items that are up there. And also, frankly, very worrisome when we know we are all up there as humans with our spacecrafts and in the International Space Station. And in space, when things are moving in that orbit, in low Earth orbit at 17,500 miles per hour, so 5 miles per second, if any one of those items, even a very small one, hits you, then you can imagine the impact that would have. So that's the big problem, are just collisions for a satellite that's up there, for example, colliding with something else and damaging it, or for our human space platforms as well. So it is a large problem, and continues to be a larger one as more countries launch things, or a country launches something, there's a catastrophic failure, it doesn't even make it all the way to where it intended, and it breaks up into smaller pieces. So that's where a lot of this stuff is coming from. There have been some efforts, different companies and entities that have been looking at ways to clean up this debris. And unfortunately, there hasn't been a great answer. There have been various proposals out there, but of course, it would be a very expensive endeavor as well. But it is something I think that we are going to have to find a solution to in the future, because the problem is only becoming increasingly worse.
It sounds like you're talking about plastic in the ocean rather than space junk. I mean, we have the same problem, right? We have gyres in the ocean where plastic is accumulating, creating sort of clouds of material in the same way that it is in space. And, at Ocean Conservancy, we host the International Coastal Cleanup every September. We bring about 1 million people around the world out to clean up local beaches to try to get this material out of the ocean, or to keep it from flowing in the ocean. So maybe we need a international coastal cleanup, but in space.
Yeah, absolutely. I think we need a lot of cleaning up, both on the Earth and off the Earth, for sure. And I think just like with environmental problems here on Earth, we need to take that step back and remember the 2 other steps that are really vital, instead of just cleaning it up. And that's, of course, reducing our usage of these plastics and reusing plastics if we have to use them, or finding some solution for that so that we don't further contribute to the problem that we already have.
Super, super interesting. I knew there would be great connections between the ocean and between space in my conversation with you. The other big thing that the ocean does for us is it creates food. Nutrients, water, sunlight produce plants in the ocean as they do on land. That can either be a direct food source for humans, or becomes incorporated in the food web in terms of much of the fish and shellfish we eat. In space, there are none of those things, right? So how do we think, how are you at NASA thinking about making food as we continue to explore the universe? My sense is that in the International Space Station, you bring your food sources with you, but there's been a lot of discussion, of course, about going to Mars. And my sense is that you would need to think very differently about food sources and water sources in terms of that long distance exploration.
Yeah, absolutely.
Can we bring an ocean with us to produce the food for us?
I wish we could. I really wish we could. But yeah, that is a great point. And that's something, the way that we live and work currently on the International Space Station isn't always a great example for how we actually need to go forward and be more sustainable when it comes to longer duration spaceflight. So when we go all the way to Mars, that's going to be really a 3-year mission. We absolutely cannot bring all of the food and water that we need with us. We have to have some other solution. So one of the things that we are doing on the space station is demonstrating some of those technologies. So for example, on my mission, we were actually growing lettuce. We grew Mizuna lettuce, and we were comparing 2 different wavelengths of light, one with a more red wavelength and one a little bit more blue. And then also we were comparing some differences in fertilizer. And we were watering and taking care of those plants every day. And then the great part was that at the end, of course, we had to harvest and package half of the samples to go back to Earth to be analyzed by the scientists. But then we also got to have a space salad. So that was a real treat for us, since, you know, normally we don't have many fresh fruits and vegetables up there, since we're sending up mostly dehydrated foods. And so that's a real treat to have that. I eat salad pretty much every day here on Earth. So that was a big bonus. And even the psychological effect of taking care of something that's green and growing and alive is huge when you're living in this kind of austere and sterile environment like the space station, especially for someone like me that has this connection with nature and always wants to be outside. It was really nice having that. So that's an example of what we will need to do for the development for future exploration systems. These kinds of sustainable food systems will be absolutely paramount to that, because, you know, like you mentioned, we can't just pull that food out of thin air like we might want to in space.
Yeah, that's fascinating. I mean, it gives a new definition to farm to table, right?
Yeah.
So I want to take just a few minutes here, and this has been really, really fascinating. I want to touch on one other topic with you, which is not about the oceans and not about space, but about people. So, you know, one of the things that we see a lot on Earth now is massive division among people. We certainly know that here in the United States. It seems like nobody can get along and everybody's fighting about everything, including the environment, but lots of other things too. And it strikes me that, you know, on the space station, you need to figure out how to work with people from different backgrounds. My understanding is that you trained with the Russians on your first mission. And I'm just wondering, again, what have you learned about working with people in space that has implications for how we work together here on the planet to solve some of these big problems?
Yeah, you're absolutely right. I think the International Space Station is a great example of what we can do when we put our differences aside and work together on a common goal. You know, it's the International Space Station. It's not just NASA, it's also the Russian Space Agency, the Canadian, European, and Japanese space agencies. And particularly at a time like this, given the political climate, for me, living and working and training in Russia for almost the majority of the year and a half before spaceflight, you know, that's a pretty unique, special opportunity given what's going on our planet. And I think it's such a powerful example. You know, when we are on there on the International Space Station, working and living 24/7 with our Russian counterparts, all of our cosmonaut crewmates, and as well as our international partners. I was up there also with an Italian astronaut at the same time. It's such a powerful example of what we do when we work together. I can tell you that when we are up there on the International Space Station, we are certainly not thinking about any of our political divisions and differences between us and the Russian space partners, for example. That stuff is, we just realize how insignificant it is when we put our minds together for good instead on this common goal that we're accomplishing up there for spaceflight and exploration. And the other big part of it, I think, is what we were talking about kind of toward the beginning of the interview, talking about this perspective of looking down on the planet and seeing how we are all truly in this together. That is so plain to see from the space station. We have one planet. All of it is connected. We don't have those man-made geopolitical boundaries like we were talking about. That was all imposed by man. And when you have the privilege of seeing this view of our incredible planet from above, you can't not see that. I mean, it is so clear that we have one thing in common. We are all humans that are sharing this home on our planet. And unfortunately, our home is in peril. You know, the oceans, the environment are struggling because of the impact that we have brought upon it. So I think this perspective that I have been so fortunate to have is such a powerful and special one. And that's why I wish I could bring with me everyone's eyes of all the other humans on the planet. Because if people have this perspective, I think it can really change how you think. You know, I know how easy it is to get caught up with superficial things or whatever's happening right in front of you. That happens to me as well. But I remind myself of how I felt when I looked back at our planet to try to put that into perspective and try to make positive change and not get caught up with those small things like we do. You know, I said that a lot during my mission too. You know, I think in addition to bringing all the humans, I wish I could at least bring all of the world leaders, because I think if they had that powerful paradigm shifting view that we have as astronauts on the space station looking down, it might help drive a lot of their strategies and policies and decisions, and might help them appreciate how we really need to be working together and thinking about how we are all connected and we are all one in order to solve this climate change problem, which is something that is absolutely affecting the entire planet.
Yeah. Well, Jessica, you are truly an inspiration. And I think this is really about inspiration. Right? We find the ocean inspiring, and we think that we need more people thinking about the planet and about a healthy ocean. And that includes, I think there's a real role for space and the NASA program to, help us all understand how important this planet is to all of us.
Yeah, I totally agree, especially with this current administration and their emphasis on climate science. And like I mentioned, this new effort with the Earth System Observatory, it's nice to see that we are moving toward heading in the right direction. And I hope that that trajectory and that momentum continues.
Yeah. Well, so my last question for you, Jessica, is really, you probably get this a lot, but given you are such an inspiration, if you were talking to a little boy or a little girl who wanted to do anything, you started in Maine and you've literally flown to the stars. Like, what is your advice to anybody who's young, who wants to make a difference in the world? What advice would you give them?
Yeah, I think the first thing is identifying what it is that you're truly passionate about. We started off talking about that early inspiration of the oceans. Was it space or the oceans first? And what was that drive? And that's what it was for me, this exploration, biology, space. And that was for me what really drove me and inspired me. And so I worked toward that. I majored in biology, and then I kept this path toward the stars in the back of my mind, always involving myself in any space-related activity and working really hard to get there. And so I think that's the biggest thing to remember, to find that one thing that you're passionate about. Because I think if you're not working at that goal, then you're probably not going to be successful. And more importantly, you won't be happy doing it. And then realizing that you need to be able to take a risk, to push yourself sometimes slightly outside of your comfort zone, because that's when the good things really happen. To be able to take those risks and to realize that it's also okay to fail. That failing along the way is often the time when you have the greatest lessons learned in order to get that success in the end. So that's the advice that I would give. Find that passion, work really hard toward it, be willing to take a risk, and don't be afraid to fail.
Well, that's fabulous. And I know you are training to head back to the moon. That's very exciting. But if you get some time to come to California, I'd love to go explore the kelp forest with you.
Absolutely. That would be really wonderful. I very much miss those days diving around the La Jolla area. So hope to get back there soon.
Okay. Well, good luck with your next mission. And again, thank you very much. I appreciate the time. This has been really, really, really interesting and insightful.
Okay. Thanks to all of you. Take care then. Keep up all the good work protecting our oceans.
Okay. You too.
All right. Take care.
Bye-bye now.